In this tutorial, we're going to start with a Google Sheet. So I want to go to sheets.google.com, create a new blank sheet, and we're going to look at a couple examples of things we can do in Sheets and then recreate how to do those with a little bit of programming using the Python programming language. So we can compare these two methods and see what their relative strengths and weaknesses are. We can give this file a name. Let's suppose I wanted to make a list of the squares of the first 10 natural numbers. I could have 1 here and 2. You may recall if I highlight both of these by holding Shift and clicking in the second cell, then moving my cursor until it's in the lower right and I get a black cross, I can drag this down to 10 and I have the numbers 1 through 10. Now if I want to have the squares of those numbers, here in column B I can type equals, click on A1, and Shift 6 gives me a caret, 2 squares the number, and then again applying that formula, I get my black cross in the lower right, click and drag down, and we see the squares of those numbers. We can graph them. Probably we want a scatter plot, but I have to tell it that, so that's an example of something we can do with a Google Sheet. What's another task we could accomplish? Suppose I have another set of numbers. My first number is 0, my second number is 1, and now I'm going to make a rule that my next number will equal whatever the previous two numbers were added together. What will happen if I apply this rule over and over again? Let's take a look. We get the series 0, 1, 1, 2, 3, 5, 8, 13. You might know these numbers. This is called the Fibonacci sequence, and it has a number of interesting properties that we'll take a look at later. So these are interesting and useful automations of formulas that I can do with a spreadsheet. It's pretty easy to learn, fairly intuitive, but it does involve quite a lot of clicking and dragging, and if I wanted to modify this to be, say, the cube of the number, I would have to click and drag this down again to change the values there. So not too bad, but if I had a very large data set, this might become a bit unwieldy. So we're going to see a different tool for accomplishing these same kinds of tasks. To do this, I'm going to go to colab.research.google.com, click on Google CoLab, and I already have an account here, but you can sign in with your email credentials. Link this to your Gmail account. I'm going to make a new notebook. Here we're given a prompt. I'll name this notebook. And we're going to do the same things we did in the previous example. First, a little bit of explanation. I can assign numbers to names, like I can say A equals 1, B equals 2. These spaces between the letter and the equal sign do not matter. There are times when space will matter. I click on the play button, and it has executed this code. Another way to execute the code is to hold Shift-Enter. It will not only execute it, it will also generate a new cell, but this notebook remembers what we did in the previous cell. So if I type the name of A and execute this code, it will echo the value of A. Echo means it tells you what the value of that variable is. So just by typing A, the thing that's returned is the value of A. If I type A plus B, this works like a calculator. It can tell me 1 plus 2 is 3. What other functions work? Let's try 1 divided by 2, 0.5. So this all seems handy. But let's return to our squares example. I can delete this second cell. I don't need it right now. If I want to do something a certain number of times, and I know how many times I want to do it, I can use a structure called a for loop. I'm going to type the word for, and if I spelled one of these special commands that are part of the Python language correctly, they'll turn purple. I need an incrementer variable. It's just a dummy variable that's going to change as we repeat this procedure for I in range of, let's say, 10. Notice it automatically completed parentheses for me. I need a colon to say we're beginning this loop. I hit enter, and notice that we have indented. In this case, we've indented 2 spaces. These are line numbers on the left. They just make it easier to discuss code. Here on line 2, I will say print parentheses I, and whereas we used Shift 6 caret in the spreadsheet, The way to get an exponent in Python is star star. That means raise it to this power. I star star 2, print I squared, in other words. Let's execute that code, and I see printed separately on each of these lines are the squares of which numbers? 0 to 9. So this is important. Ranges in Python begin at 0, and they go up to 1 less than the number that you've asked for. This range 10, this was pretty simple, but I have each of these numbers just separately printed to the screen, and I'd like a way to store them in a list. So we're going to add a little bit to our code, adding another line here. To do this, we're going to make a new structure called squares, which will store our squares, and this is a type of structure called a list. To make a list, we use square braces like this in Python. This is currently an empty list. Now we'll change the guts of this for loop a little bit. Remember that I need to be indented, and here we're indenting 2 spaces. We're going to say squares dot append. Append means add this element to the list, and I get a little help here. Append object to end. Append it to the end of this list. If there's no elements, when we add an element, it will have 1 and then 2. And this should give us a list of the squares of the numbers 0 through 9. I'm hitting enter, and notice that I'm still indented. So by default, we're still in this loop. To get out of a loop, we need to unindent. I like to insert a blank line to make it easier to read, but that's optional. Here I've unindented, and I will say print squares, and let's execute that code. So here we see the list containing all these numbers. So what can we do with a list to get another cell? I'm holding shift and hitting enter. What if I asked for squares plus squares? Let's see what happens. What did it do? This concatenated the list with itself. So I have one copy of the list here on the left, and then another copy just jammed on the end. This is maybe not what you expected. I don't know if you expected to get 0, 2, 8, 18, something like that. How could we make that happen? Well, lists don't have that property that we can do mathematical operations with them, like plus, or even more complicated operations than we might want to do later. For that, we need a structure that's very similar to a list, but it's called an array. To use an array, I need to import a library. The library we want to import is called numpy, or numpy. People pronounce it differently. We will say import numpy as np. What does this as mean? NP is the symbol we're going to use whenever we use something from NumPy, and this is just a shortcut so we don't have to type out the whole word. So it makes the code easier to read and more compact. How would I know what's in NumPy? Well, the short answer is I learn with experience. But maybe a more useful answer is I can execute this code, and now I've loaded NumPy as NP. With this, I can look up what is contained in that np module. I'm using this function dir, what is in the directory np, executing that code. I see all these functions. Scrolling down, there are a lot of useful functions in here. I see a lot of trig and other mathematical functions. Right now we don't need those. I know what the tools are that I would like to use. We're going to say squares equals np.zeros of 10. Let's check out what that does. We'll print squares and then execute the loop and print squares again. Let's take a look. Shift enter to execute. I can't append to an array. That is not something that we do. In this case, instead I want to give the address of squares. The ith element of squares goes in square braces like this, and rather than append, we will just say equals I squared. These parentheses are no longer needed. So we have a box 10 elements long. It's initially filled with zeros, and then we're going to fill each of those elements with I squared. Try again. There you can see I started with a box, an array, full of 10 zeros, and then I replaced each of those zeros one at a time with the values 0, 1, 4, 9, the squares of the integers. Let's see now what happens if we add squares to squares. We get the more expected mathematical behavior that we've added squares to itself. A virtue of this method, as opposed to what we were doing in a spreadsheet, is suppose I want 2,000 numbers. I could set n equal to 2,000 and then replace wherever I have a 10 here with n. This is a good practice. Instead of putting in a number, define the number with a symbol, and then we won't have to edit in a lot of different places again. If we execute this code now, it kindly gives me some triple dots here. I don't need to see all the detail just now, but I have a list that is 2,000 long. To see that, I could ask for len of squares. Let's see what happens. And it tells us the length with this len function is 2,000. In the spreadsheet, we were able to make a plot. To do that with Python, we need a library. We're going to import matplotlib.pyplot as plt. Now to make this plot, we can create a figure, plt.figure. The figure command is part of the plt module. Why did it not know that plt is part of my program? I need to execute the first cell again. Now try it. I've created a figure, but there's nothing in the figure. To put something in, we can say plt.plot squares, and let's see what happens. We get a smooth curve here. By default, it's blue, and it is showing me the squares of the numbers 0 to 2,000. Well, 0, careful, 0 to 1,999. And what's going on here? I have 4, and this 1e6 means times 10 to the 6. So about 4 million. We can check that. What's 1999 squared? Remember star star 2. Tells us the answer. Execute that code, and we can see that's almost 4 million. Can we check what the last element of the list is? Let's ask it to print squares of the last element. Which element is that? Element 2000, is it? Let's check. Out of bounds. Remember, the last element is one less than the number of elements. Trying again, and we can see printing squares, we get the same number. Squares of the last element. Another handy thing to know is to ask for the last element. We could also say -1. That just means count elements from the right end of the list, and we should get the same number. Let's try it. There you go. Let's go back so our data set is not quite so big. I'm going to change n back to 10 and re-execute this top cell. Re-execute my figure cell, that's with the shift click, and I'd like to modify this a little bit, comma, and we'll say single quote r lowercase o. R is for red, O is for circles, shift enter to execute, and now I can see the actual data points themselves. You can guess what'll happen if I change this to green. Sorry, to G, I get green dots. What if we tried, instead of O, S? Any guesses? This gives us green squares. G asterisk gives us green stars. So there's your first Python program. We imported 2 libraries, or modules. We defined an array. We saw that an array is like a list, except we can do math with it. We've seen how to print values to the screen, how to use a for loop to add or modify elements in the array, rather, and how to use the matplotlib pyplot library to generate a simple graph. In the next video, we'll see a few more things that we can do with Python.